When sizing wires for a subpanel, it's crucial to adhere to the National Electrical Code, or NEC, to ensure safety and proper operation. In your case, you ran 3 number 40HHN wires and 1 number 80HHN wire to power the subpanel in the barn, supplied by a 50 amp 220 volts breaker in the main panel. The number 40HHN wires for the hot legs are rated to handle 70 amps, which is adequate for a 5000 watt load. The number 80HHN wire for the neutral is sized for 35 amps, also generally adequate for your described use case. However, the number 80HHN ground wire is too small for a 50 amp circuit. The NEC mandates a minimum ground wire size of number 6 AWG for a 50 amp circuit. Addressing the grounding configuration, it is recommended that you use a local ground rod in the barn for grounding. Do not depend entirely on the grounding at the main panel. The ground rod serves as a local grounding path for potential faults in the barn. Regarding the neutral and ground separation in the subpanel, maintain separate neutral and ground conductors. Do not connect the neutral to the ground rod or the subpanel enclosure. The neutral should only be connected back to the power source, which is the main panel. For additional safety measures, firstly, install a surge protector in the barn to safeguard against power surges. Secondly, use a GFCI outlet for any outlets situated near water sources. Thirdly, have the electrical work inspected by a qualified electrician to verify that it complies with all safety codes. Given the information above, you should revise the wiring plan. Firstly, run a number 6 THHN wire for the ground instead of number 8. Secondly, connect the ground wire to the ground rod in the barn. Thirdly, ensure that the neutral and ground conductors are kept separate in the subpanel. Understanding grounding further, grounding is a critical safety measure in electrical systems. It provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This helps prevent electrical shock and fire hazards. Grounding systems can be complex, so it's essential to understand the basics. There are primarily 2 types of grounding systems: equipment grounding and system grounding. Equipment grounding connects all non-current carrying metal parts of an electrical system to ground, such as metal enclosures, conduit, and equipment frames. This ensures that if a fault occurs and a metal part becomes energized, the fault current will flow back to the source, tripping the overcurrent protection device. System grounding, on the other hand, connects the neutral point of the electrical system to ground. This helps stabilize the voltage and provides a reference point for the system. The ground rod you drove into the ground at the barn is part of the equipment grounding system. It provides a local grounding point for the subpanel and any equipment connected to it. The number 6 AWG ground wire you will run from the main panel to the subpanel will connect the subpanel's grounding system to the main panel's grounding system. The purpose of keeping the neutral and ground separate in the subpanel is to prevent neutral current from flowing through the grounding system. If the neutral and ground are connected in the subpanel, some of the neutral current will flow through the ground wire back to the main panel. This can create unwanted voltage drops and potentially energize metal parts of the electrical system. To ensure that the neutral and ground are properly separated, use a separate ground bar in the subpanel. Connect all of the ground wires to the ground bar and the neutral wire to the neutral bar. Make sure that the ground bar is bonded to the metal enclosure of the subpanel. In summary, using the correct wire sizes, implementing a local ground rod, and maintaining separate neutral and ground conductors are critical for safe and effective subpanel installation. Consider consulting with a licensed electrician to ensure that all work complies with local codes and regulations. When planning the electrical layout for the barn, consider the future needs. Even though the current estimated maximum load is around 5000 watts, it is wise to account for potential future expansion. Overestimating the load requirement slightly can provide flexibility later on without needing to replace wiring or upgrade the subpanel. To calculate the load requirement, list all the electrical devices that will be used in the barn, including the 5 horsepower air compressor and the tiny wire welder. Determine the wattage of each device. For motors like the air compressor, use the nameplate amperage to calculate the wattage. The formula to calculate wattage is watts equals volts times ounce. For a 220 volt circuit, the wattage would be 220 volts multiplied by the amperage rating of the motor. Add up the wattage of all the devices to determine the total load requirement. It's a good practice to add a safety factor of 25% to the total load requirement. This will account for any unexpected loads or simultaneous use of multiple devices. For instance, if the total calculated load is 5,000 watts, adding a 25% safety factor would bring the total to 6,250 watts. This is the minimum capacity the wiring and subpanel should be able to handle. Selecting the correct breaker size involves choosing a breaker that is appropriate for the wire size and the total load. The number 4 THHN wires that were originally installed can handle 70 amps, which is more than sufficient for the 50 amp breaker currently in use. However, the breaker size should never exceed the ampacity of the wire. The purpose of the breaker is to protect the wire from overheating and causing a fire. If the breaker is too large, it will not trip in the event of an overload, and the wire could overheat. The NEC provides tables that specify the allowable ampacity of different wire sizes and types. Consult these tables to ensure that the selected breaker size is appropriate for the wire size being used. When choosing a subpanel, select one that has enough spaces for all the required circuits. It is always a good idea to choose a subpanel with extra spaces for future expansion. The subpanel should be rated for the maximum load that it will be carrying. The subpanel enclosure should be made of metal and be properly grounded. This will help protect against electrical shock and fire hazards. Installing a surge protector in the barn is a wise investment. Surge protectors help protect electronic devices from voltage spikes that can damage or destroy them. Voltage spikes can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from electronic devices and into the ground. Choose a surge protector that is rated for the voltage and amperage of the electrical system. The surge protector should be installed at the subpanel to protect all of the circuits in the barn. GFCI outlets are essential for any outlets that are located near water sources, such as sinks or hoses. GFCI outlets protect against electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path, such as through a person's body. GFCI outlets will trip and shut off the power when a ground fault is detected. This can help prevent serious injury or death. GFCI outlets should be installed in all wet locations such as bathrooms, kitchens, and outdoor areas. Consider the environmental conditions when selecting electrical components. If the barn is located in a damp or dusty environment, choose components that are rated for those conditions. For example, use weatherproof outlets and light fixtures. Use conduit to protect the wiring from physical damage and moisture. Grounding electrodes are crucial for providing a low impedance path to ground. The ground rod that was installed is one type of grounding electrode. Other types of grounding electrodes include metal underground water pipes and concrete encased electrodes. The NEC specifies the requirements for grounding electrodes. The grounding electrode system should be properly installed and maintained to ensure that it is effective. Regularly inspect the electrical system to identify any potential problems. Look for loose wires, damaged insulation, and corroded connections. If any problems are found, have them repaired by a qualified electrician. Consider having a qualified electrician perform a comprehensive electrical inspection of the barn every few years. This will help identify any potential safety hazards and ensure that the electrical system is up to code. In summary, safety should be the top priority when working with electricity. Always follow the NEC and other applicable codes and regulations. If there are any doubts about how to perform an electrical task, consult with a qualified electrician. When working with electrical circuits, always turn off the power at the breaker before starting any work. Use properly insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical circuits when they are wet. Be aware of the potential hazards of electricity and take steps to protect yourself from them. It is also important to understand the specific requirements for agricultural buildings. The NEC has a separate section that covers the electrical requirements for agricultural buildings such as barns and stables. These requirements are designed to protect livestock and prevent fires. Some of the specific requirements for agricultural buildings include the use of ground fault circuit interrupters, or GFCIs, in certain locations, the use of dust-tight and watertight enclosures, and the proper grounding of metal equipment. Make sure to consult the NEC and local codes to ensure that the electrical system in the barn meets all the applicable requirements. Proper grounding is crucial for livestock safety. Stray voltage can be a significant problem in agricultural buildings. Stray voltage is a small voltage that can be present on metal equipment, such as waterers and feeders. This voltage can be caused by improper grounding, faulty wiring, or other electrical problems. Stray voltage can cause livestock to become stressed and may even lead to health problems. To prevent stray voltage, make sure that the electrical system is properly grounded and that all metal equipment is bonded together. Consider using an equipotential plane, which is a grid of wires embedded in the concrete floor to equalize the voltage potential throughout the building. Surge protection is particularly important in agricultural buildings. Agricultural buildings are often located in rural areas where they are more susceptible to lightning strikes. Lightning strikes can cause significant damage to electrical equipment and can even start fires. To protect the electrical system from lightning strikes, install a surge protection device at the main panel and at any subpanels. The surge protection device should be rated for the voltage and amperage of the electrical system. It is also a good idea to install lightning rods on the barn to protect the building from direct lightning strikes. Regular maintenance is essential for ensuring the safety and reliability of the electrical system. Regularly inspect the electrical system for any signs of damage or wear. Look for loose wires, corroded connections, and damaged insulation. If any problems are found, have them repaired by a qualified electrician. It is also a good idea to have a qualified electrician perform a comprehensive electrical inspection of the barn every few years. This will help identify any potential safety hazards and ensure that the electrical system is up to code. Finally, keep accurate records of all electrical work that is performed on the barn. This will help with troubleshooting any problems that may arise in the future and will also be helpful when selling the property. The record should include the date of the work, the name of the electrician who performed the work, and a description of the work that was performed. By following these safety tips, the electrical system will be safe, reliable, and up to code. Remember that electricity can be dangerous, and it is always best to consult with a qualified electrician if there are any doubts about how to perform an electrical task. The importance of professional inspection cannot be overstated. While it's possible to perform electrical work, having a certified electrician inspect the work is essential. Firstly, they ensure compliance with local and national codes, safeguarding against potential hazards and legal issues. Secondly, their expertise identifies hidden issues that might be overlooked, preventing future problems. Thirdly, a professional inspection provides documentation for insurance and resale purposes, adding value to the property. In addition, consider the specific electrical needs of the equipment. The 5 horsepower air compressor and the tiny wire welder both require 220 volts power. Ensure that the 220 volt circuit is properly wired and that the receptacles are compatible with the equipment. It's also important to consider the duty cycle of the equipment. The duty cycle is the percentage of time that the equipment can operate continuously without overheating. If the equipment has a low duty cycle, it may be necessary to install a separate circuit to prevent overloading the existing circuit. Wire gauge is also a critical consideration. The wire gauge must be large enough to handle the amperage of the circuit. If the wire gauge is too small, the wire will overheat and could cause a fire. The NEC provides tables that specify the allowable ampacity of different wire gauges. Consult these tables to ensure that the wire gauge is appropriate for the circuit. Also, consider the type of wiring to use. There are several different types of wiring available, each with its own advantages and disadvantages. THHN wire is a common type of wiring that is used for indoor applications. It is heat resistant and moisture resistant. UF wire is a type of wiring that is used for underground applications. It is moisture resistant and sunlight resistant. When choosing the type of wiring to use, consider the environment in which the wiring will be installed. Make sure to use the appropriate type of wiring for the application. Finally, proper installation is essential for ensuring the safety and reliability of the electrical system. Make sure to follow all the manufacturer's instructions when installing electrical equipment. Use the correct tools and hardware. Be careful not to damage the wiring or equipment during installation. If there are any doubts about how to install the electrical equipment, consult with a qualified electrician.